feed technology. So we already know that the fish has different nutritional requirements, that the diet is important for the microbiota, but the pellets that we make, they are extremely important for the fish as well. It should, yeah. So it's just a little bit of history is that until the end of 80s, for the salmon industry, dry feed was what was put it together through to pellets. They were mixed, grounded, and using steam to make pellets. However, there was a lot of problems although this works fine for low fat content, it was a huge problem since that salmon requires high inclusion of fat, and these dry ingredients with steam, they were not able to absorb enough fat for salmon because they needed more energy. So until the time that they actually start, so what they are doing in the beginning, they were using this, they call it this jelly feed, that there was ground fatty fish with some flour and gelatinized starch, and they made this soft feed. But they were really poor, technically speaking. They were really poor, and they will accumulate under the cages. That was not good for the environment, for the fish as well, because they were an aerobic environment and there was a lot of production of toxic gases. So what they end up to realize is that extrusion was the solution for several reasons, because the pellet was stable for longer and also was able, through vacuum coating, to have a high inclusion percentage of fat. So if we see the salmon feed versus farm animal feed, this dry pellet by steam, you can see that a lot of fat and protein on the salmon one on the top, and then you have much less fat, but some much more carbohydrates on this diet. But why or which factors we need to consider when we are designing the diet? We need to concern about the fish species that we are talking with. We also should care the stage where they are, if they're larvae or smolt, the size of it, of course, because if the pellets are bigger than the mouth, then fish will not be able to eat. We should have targets to fulfill related with growth or with feed conversion ratio. The water temperature is also really important. The system that we are working with, if it's an open closed RAS, also is not written here, but also the salinity of the water, in the way that high salinity requires more dense pellets, otherwise they will just float. I'll talk a little bit more later. And also some health related issues or stressors, that it's important to know how to produce that feed and what to include in that feed. While we process the feed, while we produce this feed, it's really important to see the particle size, not the pellet size, but the particle size as well. We want to prevent spoilage. We want the pellets to be attractive for the fish. You want to increase digestibility. And when I'm talking to my students, I always say that you can give a steak, but if you give a cooked steak, you get much more nutrients from that. And that is the same with the processing the food, the extrusion, just with the temperature. Just by heating the feed, cooking the feed, then you have a higher digestibility, for simple reasons that nutrients are more available. We also want to make sure that there is a higher surface area from chemical and enzymatic reactions. This is why I mentioned the particle size and not just the pellet size. Because the pellets, for salmon, they must contain the correct amount of all nutrients, including the additives and the anti-nutrients should be destroyed. And I'll talk in the very end about these anti-nutrients. So theoretically, in every gram of feed, we should have the same ratio and all the nutrients required. Another qualities that we need to concern, it's the stability in the water. We want a pellet that holds well in the water, sinks in the right velocity, and I'll talk more about it. It should be hard, so it doesn't, while the feed goes through the pipes, they don't break, but should not be too hard, otherwise the fish cannot digest it. And should not leak fat. That is also another really important because fat is the main source of energy for salmon. And if the pellet goes and leaks fat, it's bad for the fish. And also, if you have in the RAS system, then you don't want too fatty water that will clog your systems and filters and so. So you can have some hand feeding that is used. It was done in the old days and is also still used for the small fish. However, nowadays, when you're talking about big facilities, we have these huge silos where the feed is um, stored and goes through pipes distributed for the different nets. Uh, yes, so yeah, that is what I want to say in this slide. However, we also need to start thinking about the feeding of the future. What fish or what the systems will require in the future. One of the, um, the novel of more technology advanced production is when the cages they can go up and down vertically. Um, in the they can go deep or come to the surface, and when they are deep, you cannot just feed from the surface. So actually, most likely we'll start using more and more underwater feeding. Also, we need to think about functional feeds with active compounds. For example, have oral vaccines or probiotics. Or we want to do a condition-sensitive coating. That, for example, we want certain compounds to be released at a certain pH or a certain temperature. That could be in the way to deliver really sensitive compounds that to pass the intestine, to pass the stomach and just be released in the intestine, for example. So there is two main difference of what we do in our faculty or in our work in small scale research. We can have some cold pelleting or extrusion. I will start with cold pelleting. And so this is just some examples that, for example, we are producing here two different diets. These are really small amounts. So these were even a smaller experiment. All of the ingredients were here. We had fish meal and wheat and gelatin. And when I say gelatinized, pre-gelatinized starch and the oils, you have all these ingredients here. They are placed we mix all the ingredients. Here we are just adding the oil. I hope you can see I think you can see the movie as well, right? I hope so. And then we could have, then after putting all the oil and water and some gelatin, then it becomes this homogeneous solution or mix, which what we'll do after, it's to literally to put in the pasta machine. We call it cold pelleting, but we also call it, this is a machine that they use in the Italian restaurants that you put all of the ingredients, all the mix here from the top. And there is a screw that will push the dye out, comes from a die. And that just here is how it comes out, for example. Um, uh, it's just a continuous coming out just to show you that what you can control here is the diameter of the pellet. But once you put some knives here in the front, um, then you will see that becomes these small pellets just because you have some knives rotating relatively fast. and then you have the pellets that you want, that the size that you want. Yeah, and then we have. Yeah, and then once you have that pellets, you need to dry them. That is just a machine, hot air going inside. The pellets are standing here in the grid. The air goes up. Here we have another fan that pulls the air. So there is always this continuously hot air going, and that is the simplest way of making pellets for a small experiment. Another way to make pellets is through extrusion, and this is at small scale. When I say small scale, because this is actually this what you see here, it's the small extrusion, the small screw where our diet goes. And I will show what the advantage of these are. Well, I will elaborate a little bit more, but is that we have lower moist, we have high temperatures, and we have some high pressure to produce these diets. And the fact that you have a high pressure makes that the pellets, once they come from a high pressure environment to a low pressure, once they come outside, they expand. And I'll give you here an example. This is, yeah, here is a video. You can see that it's expanding a lot. It's a 2 millimeters die. This is over expanding on purpose. And the feed are coming. Um, um, yeah, it's no knife yet. This is just for demonstration, but you clearly see that there is a lot of expansion. Yeah, as I said, more than enough. So here is an example how it's just by changing temperatures and pressures and changing different characteristics, we can go from no expansion at all to bubbles start appearing until the point that the bubble starts so often that here was like this over expansion that I was doing on purpose. Normally, you probably want a product like here. Yes, so when you have a small experiment at research level, you can have the extrusion or the cold pelleting. And what are the pros and cons? The cold pelleting has the advantage that is ideal for small trial and requires less material. Because if you are not satisfied with the quality of your pellets, you just put it back to the machine and you repellet them. There is no loss of material. And it's optimal for sensitive ingredients, because if you have something that is temperature sensitive, then there is no risk of disintegration of your active compound. However, the disadvantage is that it requires pre-gelatinized starch, and it has less water stability. It's not used for fish industry. So sometimes when you have a product with a paper that you work with cold pelleting, that is normally a complaint that we get. And there is more chances to spoil because there is higher water contain, and the you don't destroy the bacteria, don't inactivate the bacteria. However, if you work with extrusion, um, the advantage is that you have a much more stable pellet. It's increased digestibility. It's related to the industry, and it has a much longer shelf life. However, it requires a much larger amount of ingredients because you are not able to reuse the pellets. Once they came out, they need to be used. They cannot be reused. And there is a lot of high temperatures and pressure, so some ingredients can be sensitive to that. And of course, there is much more technical. It needs much more experience to work with the extrude. But then overall, what makes a good pellet? So one of the things, it's um, the pellet must have well-controlled floating or sinking properties. Then the pellet should be durable, that can handles the transportation, for example. It should be attractive for the fish, both in size and also in taste. Should have a proper fat absorption, and of course fulfill the nutritional requirements and support health. And I'll try to go through all of these parameters one by one. The first one is the sinking velocity. So um, different species, they have different requirements. And in this case, for example, in one side you have the shrimp that they want pellets that they sink fast. It's okay if they go to the bottom. On the other extreme, you have catfish. You want pellets that float. Those two examples are easy. Either you have a pellets expansion a lot and they float, or you have pellets that they don't need to expand and they just sink, and then is for the that it's easy to do. The problem is the in between. So if you want, like for example, salmon, if you want a slow sinking pellet, so you need to be careful how much these pellets expand, because if they expand too much, they float and the fish don't eat it. And then, of course, salmon makes the things even more difficult because it depends on the seawater or freshwater. So they have different densities. So we need to pay attention which diet we are working with, if it's for freshwater or seawater. Then, while we are making the feed, not just the properties, but you need to think about the diameter. And the die, this is the die is the what is in the end of the extruder. It can have not just the diameter of the pellets, but how many holes it has in the die. Because if you have if you want to make uh, a pellet of just and you have a die with just one little hole, you need lower pressure or higher pressure. It of course depends, but what I mean is that a die with just one hole versus a die with 100 holes, and they both have the same diameter, it's completely different physics that go inside of the extruder. So that it's what I want to say is that diet composition and physical conditions that work well with a specific die will not work to a die with a different diameter or number of holes. Another thing that I want to stress about is that all the changes in conditions to make pellets, they are not 100% linear, not at all. For example, if you want to increase the moist of the pellets and as much more water you put more, in theory, let's say in this side, as much more water you put, more dense you think your pellets will be, because but before you reach that point, actually, you can have similar points with much less amount of water, because if you have less water, there is no cooking enough. So you need to have the ideal point that even though you have more water, there is more cooking, more steam, more bubbles, and then it has a lower density. But what I want to say is that not the change of the effect in this case is moist, is not linear all the time. It can be as a curve. Here is an example of our mini extruder that you have here. And this is just to show, no, I wanted to pause, but it's not possible. I know. Yeah. So if you see that here is it's just providing this powder, the mix of the dry ingredients. And here is the barrel. So it's just providing the right amount of ingredient. And here, even though it's not so easy to possible to see, but it's the knives going around, cutting the little pellets. Normally we work with a pressure of 25 to 30 bars. We can also control the amount of water, how much water is going. This case was 0.69 liters per hour. And here was going, wait, I want to pause it there. What I want to say, Yeah. So here we were having um, 2.1 kilo of um, of dry ingredients per hour plus the zero point 0.7 of water. So we were producing almost 3 kilos per hour. It's okay speed. It's not so fast, but it's was a small pellet, so it's relatively a lot. And what I wanted to say here is that here are the different temperatures of different zones. So from zone 2 to zone to the exit to the die. So we had the temperatures going in the peak, and then the temperatures go down in the very end. And the very end, we want the temperatures to be 100 or above, because and was 36 bar. It's quite high, to be honest. We want the diets to here to cook well, and then to don't have such a dramatic exit. So there is always a low down in the temperature. And once it goes from 30 bars to 0, of course they expand. That is the beauty of it, is to control the expansion. Sometimes with just 5 degrees down, up and down, and that is I think that is the science of it. Um, yes. So as I was saying, it goes through different temperatures, cutting, and then it goes through this pipe with the air, and then there is a funnel here that they rotate to cool down as fast as possible, because if they are cold, they hold the shape better. And then we just put them all together, and so beautiful pellets that they are not coated yet. And what I mean coating is that we need to dry them and vacuum coating. So what we do, we have this big tumble. We put the pellets there, and we know that we want to put, for example, 18% or 20% fat. So we put the oil there. Normally we warm up a little bit the oil so to be less viscous, and we close this tumble. It creates vacuum, and then it goes. I'll have a better pictures really soon. And then we have these experimental diets. We have these 4 different diets. You can see that they have different colors because they have different different inclusion levels of the active compound. But yeah, then we go to the industrial level, the industrial scale. So whatever I showed, that little machine that I show you, multiply by 1,000, and then you have the industrial perspective. But even though for us it's really simple, here is just a schematic that Biomar presents, that it's not just mixing the ingredients and make the pellets. They need to store the raw materials. They need to grind all of them. They sieve, they mix, they do the extrusion, they dry. So far, pretty similar what we do. But then they sieve again, they vacuum coating, they cool even more than we do. Also to hold the fat, they sieve again, they pack, and then they transport. There is so many sievings because you don't want to spend energy and money transporting something that you don't want to work with. So they have much more um, steps, but overall is pretty similar than to us. All of these mixing, it's extremely important because you don't want, as I said in the beginning, you want every pellet to have the same ingredients and enough in the right ratio. For that, you need to grind the ingredients in the same size, and to don't have these are different examples of wrongly mixings. Even though they have the same ratio, they are not so good mixed. Um, ah, this is the conditioner. I didn't mention before, but the conditioner, it's um, it's a step before uh, the mixing of all the ingredients. No, you mix all the ingredients, but before it goes to the extruder, they can also go through the a conditioner, and that is basically some steam that is added to the mix in the way to all the ingredients are preheated before they go through that extrusion. It helps a lot the quality. It and also saves energy overall, saves energy and time, and it's cheaper, and it's really important to do this conditioner. We don't do it in the small scale, but just by having all the ingredients at the same properties and conditions, um, it's at the big scale, it helps a lot. And then this extrusion expansion that I want to show. Let me show one thing. Yeah. So here the extrusion. So it enters here in yellow. You see that it's just a convey. And here, if you pay attention here, it has a different orientation than the others. Like they always are at this angle, but here you have a different angle. What this it happens that is it has a reverse step that push everything backwards. So there is accumulation here on purpose, and that is to force mixing. And everything that goes through, it's much well mixed and homogenized, as you can see here. And in the very end, you want to have some accumulation of material. And you see that here there is like some um, caramelization in the very end. It's because it have been cooked longer, and it makes all sense. And this is actually desired until a certain point. Because inside of the extruder, you need to consider several factors that are the viscosity of the material, and to control the viscosity, you have temperature and you have the amount of water, and there is a lot of friction between all of the material and the walls and the screw. And by having more friction, you have more pressure. By having more pressure, there is more cooking. With more cooking, there is more steam produced. More produced, there is more pressure again. So there is a lot of physics going on inside of these environments, and it's really important uh, to manipulate these conditions slowly and one by one, not putting all the settings what you want. It's like you have a ramp that you need to accommodate the machine to the conditions. So it requires a lot of experience, a technical knowledge, and try and error as well. Because whatever works for one recipe doesn't work to the next. And here there is examples of everyday feed um, that you can have as a pet feed or as a snacks, and all of them they could have some of these last two, for example, they can have the same recipe but just a different change in temperature, and then becomes more cooked than the other, or different dyes. So this we are surrounded by extrusion food without even noticing. For the next is the drying step. Basically just want to have warm, dry air, but you want to make sure that the pellet is dry all over. The reason is when you dry the pellet, you want to, first of all, you want to have extrusion because you want to have these holes within the pellet. And they are really, really important, and to be dry, of course, because you want to go for the vacuum coating. And so these holes will be the ones that will be filled with oil. So as I was showing before, you put the pellets in the tumbler, we put the oil, and then you create vacuum. What happened with the vacuum is that all the air um, inside of the pellet will come out. And then once you reach the vacuum level, you release the vacuum, and then all the oil that is surrounding the pellets will go inside the pellet. And this is what we want, is the pellet to be dry outside, but full of oil inside. And this is achieved with a good expansion and a good vacuum. If you put too much oil, then the oil will be leaking, and then you don't want to. So there is requires some testing to know how much expansion you will have, how much oil can this expansion hold. Um, for the industrial level, they know all of it. They do a lot of they have a lot of checking process, because if they keep doing bad pellets, for too long, they will lose a lot of money. In our case, we need to do some try and error in the very beginning to see how much expansion can tolerate how much oil we actually want. So here is just an example of uncoated oil, uncoated pellets with 50% of 30%. To have a 30% percent oil, it really requires a high amount of expansion. And also, there is some maths, some studies doing on the factors that actually affect the pellet quality, and it's not just the um, not just the drying and the manufacturing of the pellets, but 40% of the quality of the pellets depends on the formulation, how the ingredients um, how the ingredients go on with each other, because different ingredients have different properties. And then the particle size, not pellet size, is particle size, the particle of the ingredients. If the ingredients have different particle size, it it can affect up to 20% of the quality of the pellets. The conditioning that I mentioned that they use at larger scale, that helps for the extrusion, 20% as well. The die, the number of holes and the shape of the die itself, it's a real 15%, and only 5% is drying and cooling. That is the very end before the coat, the vacuum coating. So this is really interesting data just to pay attention how factors that we don't think about it are a huge impact on the quality of the pellets. And when I was talking about this 40% was ingredients, is also the amount of, for example, gluten and starch that the ingredients have. Because even though salmon don't need carbohydrates that much, these gluten and starch they are really important for the quality of the pellets, because gluten gives that comes from wheat, for example. They have they give elasticity and the capacity of the binding capacity for the pellets to hold everything together. And you need to have some starch as well, because you want to have you want to have because the starch is the one that helps for the expansion. That's when cooks, it expands and also makes the small holes, the pores in the pellet. So it allows the vacuum coating. So lastly, besides the ingredients, I wanted to show a little diagram that I did just to explain how many factors they're all included. So as I said, the ingredients. So again, what affects the sinking velocity or the expansion? All of this, because if they expand a lot, they sink slower. If they don't expand so much, they sink faster. So we have first ingredients. We have wheat flour, and the gluten meal that we want to control the expansion, the binding, the viscosity, the elasticity, all of this, what's going on inside of the barrel. Then we have the physics that we want to know how much of mix you are putting, how much water you're putting, which temperature you are working with. There's the screw configuration, how much rotation it goes per minute. Later on affects the pressure, and that will affect the bulk density, which affects the sink velocity. So after the expansion, pellets should have a low density, they should float, but once coated, the density will increase and they will sink slowly. However, we only know all of these results after finishing the process. So it requires a lot of testing to know your material, to know your ingredients, to know your machine. And the first time that I was doing pellets to work in the seawater, I did a bunch of different conditions. I coated them, and then I went to the fjord to place some pellets in the water to see which ones they float, which ones they were sinking. And only then I realized that I can work in that range of densities. Um, because when we are making a diet, now it comes more to the part of um, constraints. We have some limitations. we have the nutrient requirements, but must be met because I know that I need to have a certain amount of energy in the diet or digestible protein. I know that I need to have a certain amount of fatty acids, amount of amino acids, and it's as much more fat I need, more the expansion I will make, or if I have high protein, it also changes the my pellet quality. So it's really important to know the nutrient requirements that because if you don't meet the nutritional requirements, then your pellets can be beautiful and fantastic, but they don't serve the purpose. Another constraint that we have is the use of raw materials. We need some minimum of some raw materials. For example, we have a minimum of vitamins, but also some gluten because we need elasticity or and starch. And also for the companies, there is a limitation of the availability of the product because uh, you might have use your a lot of a certain ingredient that is, for example, a plant-based ingredient, but they might have a lot of anti-nutrient factors. And again, I talked in the very beginning, I promised that I'll talk about later, and it's not yet, but I'll talk soon about the anti-nutrient factors. Another characteristics are the availability of the product. If you have a recipe in the industrial level, if you have a recipe that requires 10% of this ingredient, but for some reasons is not available in the market, you need to have a plan B. You need to have a substitute. And because the fish is not waiting, if the boat arrived late because of some technical problems, you need to have an alternative. You need to keep producing feed. So the amount of raw material that you have and the availability is needs to be considered. Then feed the physical properties. So if you need to change the recipe for some reason, you know that it will affect the physical properties. I have written here the starch level might be changed, the pellet structures might change, the absorption might change, the floating characteristics might change. So it's really important to know well your ingredients so you know what will happen to the pellet later on. And then it's actually um, I was looking for the legislation, but yeah, you also need to think about the limitation that you have of your machines, they can handle, what you can do with them, and the legislation. You cannot just put an ingredient just because they might have some ingredients that they are not allowed. Like you have limitations about of zinc or some vitamin D because they can lead to toxicity or some health problems, not just for the fish, but to the consumer. Um, and yeah, this is mostly special product specification. So if imagine if you are selling a product that is rich in EPA and DHA, so you actually need to make the conditions different to accommodate these specific specifications. Um, because if you look at the production of feed in salmon industry for the last decades, you see that the amount of marine ingredients have been reduced a lot. It went from 65% of marine protein sources to nowadays to be even below 12. On the other hand, the vegetable proteins, they went for a 35 nowadays to much 40, but the interesting is also the amount of oils that we are using, much more vegetable oils. Carbohydrates didn't change almost anything, perhaps increase a little bit. And the other that is 0.4% nowadays is a little bit higher, but these novel ingredients that novel sources of proteins and oils that we are working a lot with it. What I wanted to say is that what we are used to work nowadays, it's really different from before and might be different in the future because it's are really dependent with the costs of raw materials. You saw that the fish oil have increased a lot. That's most likely one reason why I use less and less of fish oil and start using some oil from, for example, rapeseed oil, that the price have been increasing, but perhaps normalizing. So there is a difference in price while the corn is pretty stable. So, and the cost of salmon have been increasing a lot, and it's also in line with the fish oil and so on. But my point is, we were looking for alternative of ingredients to accommodate the the requirements. Um, but we need to be careful, and here is what I wanted to say about the anti-nutrients, because these are mostly or easily found in plant ingredients, and we are using much more plant source ingredients than marine. And these are present, and you need to be careful because fish, for saponins, for example, if you put too much soya on salmon, they start having inflammation in the intestine, and they get sick, they don't absorb nutrients, and so on. So during the production of these pellets, while processing is also a benefit, is that some of these anti-nutrient, they can be treated, or they can be eliminated or inactivated by using heat or some enzymes or using some alcohol extraction. So it's possible to uh, go over the situation, but once again, for that, we need to know our ingredients. So yes, so that was what I wanted to mention about feed technology, and I'm open to this. Is one thing that I'm working more in these last years, so I'm still learning a lot. So, but I guess that I'm able to answer one or two questions. Thank you.
Thank you, Dr. Sergio Rocha. I know you have a fan, Byron. Byron I know has a question over there. No,
No, that doesn't
no,
look like.
no question from Byron. So anyone from the audience would like to have any question for Sergio? Victor Vidal
Yeah.
used to be an specialist for biomass, so I don't know, he might have any questions.
I have only two questions.
Okay.
The density is only affected by the water in the feed mixture, or there are another variable too.